Okay, welcome back. In this particular recording, we're going to be talking about some of the implications, some of the characteristics of how we manage knowledge in an organization. Right? Remember, we had talked about the hierarchy of data to information, information to knowledge. So we're going to talk about how that gets done, some of the applications, some of the approaches around that. Okay, just to start off, when we talk about the role of knowledge management, it is actually probably over the past 10, 15 years, it's been an area of growth in the software industry. All right, a lot of organizations have um, recognized and understood that the importance of being able to gather and leverage knowledge in an organization, and there's been a number of different solutions that have been brought forward into the into the market. Um, Big driver on that is really we've moved, our economy is now moving to an information economy, so a knowledge, kind of a knowledge worker. So the idea is 37% of our labor force is knowledge and information workers. 55% of the GDP is driven from knowledge and information sectors. So we've kind of moved from traditional, the industrial age, um, to the information age. Now, the day that happened, there's not a demarcation. It's been kind of a gradual evolution over time. All right. So part of what, and when we look at a company, the idea of the brand, the value of the company, it's really not just simply the physical capital assets, but it's also things like we would categorize them as intangible assets. So it's going to be knowledge and brands and reputations and unique business processes. Unique things we call, the term we use in business is establishing competitive advantage. All of these things combined make come to represent the competitive advantage an organization brings to market. All right, and if you can do a a knowledge management project and be able to kind of capture and harness that, you can. There are documented case studies around where there's a very big return on investment around that. Conversely, though, a not quite well executed knowledge management project, will not necessarily, there's no automatic guarantee that if you buy a knowledge management system, you will get a good return, which is also, as we'll see over the course of the terms, true about virtually any information system. All right. So, kind of a quick recap of what we had talked about before, this idea of data as a foundation, data getting converted into information, information to knowledge, knowledge into wisdom. All right. And then there's some other dimensions of knowledge. So knowledge is kind of that, what we can derive from analyzing and looking at information, kind of drilling into information to answer questions. There's a couple different types of knowledge. So we have tacit knowledge and we have explicit knowledge. All right. So explicit knowledge is pretty straightforward. That's the stuff we know. Tacit knowledge is the stuff that's in people's heads. So tacit knowledge is a little tougher to get your arms around because it's a combination of experience plus learnings plus a whole bunch of other things, some of which are uh, easy to grasp, some of which are not that easy at all to grasp. All right. So a couple things to remember, and this is really what when we look at the modern approach with organizations. So number one is knowledge is an asset. All right. It's an asset the same way as your building is an asset or a plant is an asset. It takes different forms. It has locations. All right. And it is situational. All right. So it's also kind of squishy. All right. So it's not, it's an asset, but it's not necessarily like like a piece of equipment. All right. So it's because it exists in people's heads and it exists in different fashions. All right. So, so there's a couple of things that we're dealing with, as we're looking at the dimensions of assets and the types of things we have to, a computer system is going to manage knowledge should have within it. All right. So the value chain, as we would talk about what a value, the value chain is. Well, value chain, the terminology, you'll hear this terminology in different scenarios. All right. So the idea of a value chain is where you start, you have a series of steps. And as you move from step 1 to step 2 and step 2 to step 3, each step along the way, you're increasing knowledge. You're transforming. You're taking inputs and creating outputs. It's being transforming as we're going from A to Z. All right. So knowledge management, the definition, set of business processes developed in organizations to specifically focus on creating, storing, transferring, and applying knowledge. All right. Value chain of that is, the kind of that process as we go through it, as we're adding value as we go through. So we start off with raw data. We transform that raw data into information, and then we take that information and we translate that into usable knowledge. All right. So the steps, we traditionally go through is the acquisition of knowledge, storage of knowledge, dissemination of knowledge, and then the application of knowledge. All right. So that's kind of, as we look at that, each step along the way, we're adding value as we move from one step to the other. So as we kind of look at this a little bit more detail at knowledge acquisition, we're a lot of this is really kind of documenting both tacit and explicit knowledge, and that takes all sorts of different forms. So part of the stuff is dealing with structured data, but a lot of the stuff we deal in the knowledge domain is unstructured. So emails are considered non-structured data. They're data, but it's not like a database. There's not a particular structure to an email. All right, there's a lot of stuff. It's words that have to be read and have to be interpreted. All right. This idea of creating knowledge is where you were taking knowledge is derived from information. So what we're doing is that creation process is can take the form of devising and answering questions. Going into a set of information and deriving an answer from it. All right, and then we can track data from TPS, transaction processing systems, and from external sources. So it's not necessarily limited to what we have in-house, that can be derived from our transaction systems, but we can actually bring things from outside, all right, and then combine these things together. So knowledge storage can take a whole bunch of different forms, all right. So it can take the form of databases. So databases are the traditional form of knowledge, kind of where we work with knowledge, where we will load information and then be able to direct questions to it. That's with structured data. That's why it's going to be, those situations that'll be structured. Document management systems, kind of is dealing more with unstructured data in a lot of ways. It's papers, it's presentations. Doesn't have a structure, but it definitely has knowledge and contains, has content that we're going to want to work with. All right, and then being able to manage that, role of management, being able to manage that. Dissemination is really kind of taking it once we've consolidated it, once we've extracted it, once we have it, and we've have it in some sort of stored format. Then it's taking it back out, basically making it available. So a couple different techniques. Over the past 15 years, as we've seen more and more collaboration on the internet, portals and wikis. Wikipedia is it's just a wiki. So a wiki is a type of collaboration tool around providing a particular bit of structure and search capability for information. All right. So Wikipedia is kind of the broad application of a wiki to create an encyclopedia, but you can do wikis for a whole bunch of other things. Other forms of knowledge dissemination, email, instant messaging, kind of your interactive collaboration, search engines, collaboration tools. The challenge we run into is not a lack of information, or lack of data or lack of information, but it's being able to organize it and sort it and try to separate what's important versus what's not important. Right? So the data or the information, we have so much of it. It's really trying to filter through, and it's an exercise in reduction. Focusing, reducing it to what is going to be usable in for our particular needs at a particular point in time. All right. So a couple things you can do training, programs and informal networks and experience to help focus, out of all the stuff we've got, focus on the important questions. And then finally, where can we apply this stuff at? And there's all sorts of different areas, business practices, new processes, new approaches to how we deal with stuff, new products, new services, and new markets. So what will happen is we will have situations where we'll have maybe a particular a particular situation, where we need to we want to improve a process. Well, what will end up happening is we'll kind of understand what the current state is. We will go out and do some analysis and research and ask questions to be able to see, kind of gather, information, be able to be able to turn into knowledge, and how we can make the improvements, and then we would apply that knowledge. All right, so that's really where we say the application of knowledge. Types of systems, enterprise-wide knowledge management systems. These are big, large, complicated products specifically designed to be able to collect, store, distribute, and apply content and knowledge. All right, so a lot of what we see is empowered by search capabilities, search technologies. So we'll bring a whole bunch of unstructured data in and then index it and then be able to search it, ask questions and do searching, as opposed to queries, which is what we would apply against a relational database. Knowledge work systems are more specialized kinds of systems, specifically designed to answer questions in particular, domains. So we'll see it. Things like engineers and scientists and other kinds of knowledge workers who will be looking at that and be using it in their work in creating new knowledge. And then, intelligent techniques. So a lot of stuff we see, one of the things we've seen, once again, probably over the past 15, 20 years, is this idea of using data mining, which, we come into a situation with a large set of data and we don't know the answers. We don't have we don't know what we don't know. So part of what gets done in data mining is being able to discover patterns or relationships. So that's kind of that's really the domain of what we call data mining. All right, so these are kind of the three broad ones. The ones we see a lot of, most general organizations will have something in some form of enterprise knowledge management system, which is used as really kind of a central collection point. And then these other ones are going to be more specific applications, the knowledge work systems and the intelligent techniques. Just another kind of pictorial representation of these systems. And as we said, this is the general purpose. So this one we see here, this first one, enterprise-wide knowledge management system, general purpose. All right, so we'll see things like Microsoft has got a product called SharePoint, which is prevalent in a lot of organizations. Knowledge work systems are going to be very, more specialized. So we see things, virtual reality type systems or CAD design systems. There's different examples of these things, but very specialized knowledge work systems. And then, these in techniques. These are really, the algorithms and the type of things we do. This also comes in, we call this a part of data analysis as well. But the idea of being able to take a data set, turn it into an information set, and then be able to look through it and using these different algorithms and techniques to be able to look at the data and figure things out. As we kind of have talked about the type of systems, the types of knowledge we have is, the knowledge is contained in structured documents, formal rules, databases. All right. So, if you look at a particular structured document, that the first part will contain a particular type of data, which makes up some percentage of kind of the knowledge. But the larger share of knowledge in an organization, the way we've got stuff stored, is in what we call semi-structured documents. So it's going to be emails and videos, things that contain data, but it's not in like a database format or a structured format. All right, and then the third is what's in people's heads: unstructured, tacit knowledge. All right. So, as we say here, 80% of on average, 80% of an organization's business content, the data, when we talk about, remember, we talked at the beginning of the course about this idea of this explosion of data. That explosion of data has really been driven by this semi-structured and unstructured data, which is driving, through, emails, videos, and, different sorts of collaboration techniques. So an ECM is really the kind of the title, the name we talk about. The enterprise content management systems. It's we use the capture, store, retrieve, distribute, preserve documents and semi-structured data. So it's a computer application that's designed to work with this stuff, right? So we can bring data in from different, we can bring it from external sources. We can generate it from internal sources. We have functionalities and capabilities. We have searches. We have tools for communication, collaboration. So there's a whole bunch of different things that kind of come with these things. So it's a one kind of a general purpose application. The problem you run into, though, and just because you buy this application, there's still an exercise that organizations have to go through to figure out how you classify that data. All right, it's not an automatic. It's not a matter of you buy this thing, you plug it in like a toaster and it works. I mean, there's a whole internal effort of basically trying to identify the data, that's information that's important for that particular organization, and assigning it into different types of classification. So we have these digital asset management systems, which help facilitate that. It doesn't necessarily do it for you; it helps you do it. All right. So the idea of we kind of take all of these different types of data, put it into, some sort of common storage. And then we have the ability to kind of create, capture, tag, store, retrieve, manage, review, distribute, publish. Actually, one thing that should be in here is search. All right. So, but all of these are kind of what the mechanism is of an enterprise content management system. And then, so we have the users who are talking, working with the application, which is then working against this unified repository of a whole bunch of different types, data types and data sources. One of the challenges in an organization is really who knows how to do stuff, or who knows where things are at. So, trying to identify and locate and share expertise is really kind of a problem, because you don't necessarily, especially when we're dealing with tacit knowledge, trying to categorize who knows what is can be a challenge. So the idea is that what you'll see in some organizations, you see it in some of these collaboration systems, where you create a kind of a directory of staff, and then also kind of identify some of their skills and experience to be able to look up. So you can search, you can find people who might be an appropriate expert, or has experience in a particular area. All right. So we see this similar, what we see in the kind of the social world, social networking, like LinkedIn has that same kind of thing. But it's as valuable as it is in LinkedIn on the outside, it also has applications internally. All right, so this is not something that's restricted just to LinkedIn. It's something we can do across the board. Learning management systems, LMS. It's specialized systems specifically around the idea of focusing on employee learning and training and all the different things that are associated with that. So management, delivery, tracking, assessment of how effective and how good the training and knowledge transfer is within the organization. So once again, supports multiple modes of learning. So things like, for example, what we see, what we're using is Canvas, all right. But the Canvas, and it's we're applying it in an academic, so we're applying it in a university setting. But the same kinds of learning management systems also have applicability in organizations across the board. All right, so you can do, automate the selection administration of courses. So what you can do is if you're tracking people's skill set or experiences, you can go back and then, kind of analyze what people know, what their role and responsibilities are, what they should know, identify what that gap is, and then put together a program for them to, uh, build on that, kind of, bring your training up to speed. So it's what it does, it assembles and delivers learning content, and it also, most of these things will have a some form of measuring, the outcomes, of a course, how effective a course is. All right. Something we've seen, this was big about maybe a couple of years ago, what we called MOOCs, MOOCs, massively open online courses, which was opened up. Universities had kind of had followed down this path, like Coursera. There's a couple of a couple other ones of that ilk, where universities would actually take their courses, record their courses, and put them online. And at one point when this first came out, everybody was assuming that, well, we won't need universities anymore. I think one of the problems they found, though, is that it's very, even though you can put things out there, you get people to sign up, make it easy, and it's online, getting people to follow through and follow through like it would in a classroom environment was not that easy to do. So you'll have like 5,000 people show up, who will sign up for a particular section of a MOOC, and then at the end you'll have 10% maybe complete, 5%. The numbers on the other side, the completion numbers on the other side, pretty small compared to the people who sign up. So the massive part is the people who sign up, but that doesn't translate through into actually endpoint people completing it. Knowledge workers, as we talked about, workforce, 21st century workforce is really knowledge workers. All right. Not 100%, but for the most part, the larger percentage of workers are, have some knowledge content in what they do. All right. So there's a whole bunch of different roles, the titles: researchers, designers, architects. These are people who are dedicated to knowledge management or the knowledge type of work. All right, and really, what the roles are involved with this there's three in nature. So you want to keep organization current in knowledge. Those people can also serve as internal consultants. They have the internal expertise of different things that they're the subject matter, or the terms we use. You'll hear thrown about subject matter experts. Right? And then also there are the change agents. So they're the people who not only do they know the current stuff, but they also can be the folks who are involved with improving. When we talk about making changes to improve things, they bring their knowledge and expertise into it, which helps you make informed decisions around this. Knowledge work systems for knowledge workers to help create new knowledge. All right, so this is all. So as I said, there's part of these things will show up in these knowledge management applications. Some things are there's kind of general purpose ones, and then there's some more specific ones. One of the things they've discovered is none of this stuff is easy to do. So these large systems, you can put these things in, you can get them started. The problem is being able to make them sustainable, and being able to get an organization to adopt it as part of the day-to-day or the operational aspects of it. A couple things around these things, these kind of requirements: sufficient computing power, be able to do graphics and complex calculations. What we've seen is part of the stuff is the reason why it's shown up in the past 15 years. And the past 15 years is where we've been able to develop the types of technology capable of supporting these things. Being able to have bringing that type of horsepower to bear to be able to do graphics and analysis. In addition, communications and document management. We're talking about millions of documents. That can be accumulated. So the ability to bring them in, to process them, to search them, requires a lot of capability. All right. As we also talked about before, access to external databases. One of the things your organizations find is, okay, we have what we have what we've generated and managed internally. All right, but what about stuff that's on the outside? Research from universities or from different organizations that have, that will publish, knowledge, dealing to important areas. Being able to bring that in and synthesize the external stuff with the internal stuff. Right? And then user-friendly interfaces. So you want to make this thing so it's easier to use. The stuff people will use the term, well, it's all intuitive. Well, most computer systems are not quite as intuitive as people would think. You can learn, and if it's done well, you can learn rapidly. So we'll take an example of the iPhone. Nobody got a manual with the iPhone, but when you first saw the iPhone, it was a whole different. You first looked at it, and it was like, well, how's this work? Now it was designed in such a way so where you kind of pick up pretty quickly of how it worked. But so this idea of part of what you want to have in these kind of modern applications, and this is in general, is some sort of user-friendly interface. And finally, the other thing dealing with these knowledge work systems, a lot of these things are specifically designed for areas of work. So engineering applications or financial analysts. Not everybody in the organization is going to be doing financial analysis. Not everybody is going to be doing design of things. So these things will become more. So this is the examples we have. We talk about CAD. Creating architectural designs or 3D printing. So one of the things we're seeing in emerging technology is the ability to design be able to create a design and then transform that design into a physical object through what they call a 3D printing process. So it's really kind of kind of using different materials, to be able to create like a spray. There's a couple different approaches you see with 3D printing. So the printing term it's a little misleading. It's not really a printing process. It's actually a manufacturing process. We're creating things. All right. So virtual reality systems. We're starting to see more of this. With things like, for example, augmented reality. So what's happening? Augmented reality. The case study with augmented reality, was going back about 5 or 6 years, was like Google Glass. So Google went out and created glasses, a pair of glasses you could wear that also had built-in heads-up display. All right, so you could see things and do things. The problem with it is that it became, the first generation of these things, actually it became a negative connotation because people were thinking everybody wearing Google glasses were recording everything they were saying. So there was a negative connotation with it. But we're seeing, so that kind of went away, but we're starting to see, new forms of that, more sophisticated forms, more, aligned with the way people actually work as opposed to being kind of an add-on kind of thing. So we're seeing, a lot of these things are still kind of leading edge developments. So the business benefits, the whole idea is, you invest in an application because there's going to be a benefit to be derived. So what are these what are the benefits? For knowledge management, it's really trying to capture this stuff that's in people's heads, all right, and to be able to take it and then use it, as a foundation, and then be able to build upon that on an ongoing basis. All right, so capturing tacit knowledge is hard to do. All right, we're beginning to get there. We're beginning because we have enough capability. We have the ability to be able to generate and capture enough data to be able to do the types of analysis we need to be able to make accurate assessments. All right, and then the development of the algorithm. So things like, for example, fuzzy logic. Being able to make decisions, analysis and decisions when things are not necessarily cut and dry. It's not an either or condition, and it could be any number. It could be any number of things. All right. Knowledge discovery. So things like neural networks and data mining kind of fall into those categories. All right. developing solutions to complex problems. We talk around machine learning and kind of this artificial intelligence. Artificial intelligence has been around a long time. All right. It's only now becoming, we're kind of seeing another wave of the next generation of this stuff. First generations were very, limited in what you could do. I mean, there was a lot of, the vision was there, but the ability to actually do it was really pretty seriously limited. And, now we're kind of getting, as this is moving along, we're starting to see, we can apply more technology, we can bring more technological horsepower to bear to address these problems. And as we say, artificial intelligence, the computer systems that emulate human behavior, are designed to emulate human behavior. All right. So, this knowledge capture, I mean, the dream of this stuff has been, being able to take what is in people's heads. Somebody who's been working at a job for 30 years, taking that collective expertise and transforming it into something we can apply into a knowledge base, and then leveraging that. Problem is it's a pretty complicated undertaking. There's a lot of subtleties and a lot of, it's not a straight line process, which makes it really difficult to do. All right. And there's a lot of things. What will happen sometimes, it's not just simply a straight line. We do this, this, and this, we have this outcome. There's also successful and unsuccessful. And there's also things like, there's different characteristics and traces that can give you an indication of how something may turn out. All right. So, the idea of, your successes and failures. So we're seeing this, it's case-based reasoning is kind of what we call this. A lot of stuff is in medical, all right? So medical diagnostic systems and things of that nature. And, it's usable to a degree, but you're not necessarily right now going to be expecting a computer to replace your doctor. I mean, your doctor, probably that's, the kind of the high level of when we talk around tacit knowledge and expertise, medical, all right? And taking that kind of, tacit knowledge and translating it into some sort of application is a very tall order. So fuzzy logic is, kind of, a rule-based technology system, but what it seeks to do is also represents the imprecision of things. So cold versus cool, and it's a range of values. All right, because if because you can throw, there's different, like in the English language, we have different terms that sound the same, but they're totally different things. What does that mean? All right. So, what ends up doing with these things, these fuzzy logic, will take a particular phenomena and then represent it with, in a set of rules, relatively small set of rules that can, realistically describe something. All right. So it's really kind of the next generation of, because it's how we think. It's how people actually think. It's not a straight line if then. If then logic has been around, it captured in computers as long as we've had programs. All right. Going back to the early days of computing. It's one of the fundamental constructs of a computer program. It's something you do if then. So we're still, once again, this is not for general. This is not, has not gotten to the point of being able to use for general. But a lot of times where you'll see it in things like autofocus cameras and, being able to analyze, particular applications, kind of putting, there's obviously going to be a barrier around or a limitation around it, but it does give us the ability to create be able to make decisions and things were not necessarily direct. Neural networks around looking for patterns, or kind of how we learn or understand patterns, relationships in large amounts of data. So the advantage is, with the computing, we can feed it larger and larger and larger data sets. The problem with computers are they don't necessarily handle things with the same agility as the human brain. So this whole thing is it's kind of a brute force technique. We do, it will learn patterns, you know, looking to identify connections and relationships, over and over and over again. Right? So eventually it will learn something, but the thing that drives it is the volumes of data. I mean, if we feed these things enough and we do it enough times, eventually we start developing a understanding kind of what the different relationships are and what the behaviors will be. Um, so we'll see, so we're seeing this once again, we're seeing it in medicine, um, business, financial decision making, because what we're doing in a lot of these cases, we're looking for patterns, and then, what class does that pattern fall into? See if we can make a reasonable prediction of an outcome based upon a particular pattern, and then how we can control it and optimize it. All right. And then genetic, we're looking for an optimal solution, looking for a very large number of possible solutions to that problem. All right. So the idea of we've done optimization for years. So that's actually one of the big, there's a lot of stuff that's in statistics, a lot of things that are in analysis, linear algebra of being able to develop a problem to find the an optimized result given particular constraints. All right, so that we've done that statistically. This is kind of the next generation of that, where we can apply it in optimization problems. So minimization of cost, most efficient directions, and there's hundreds and thousands of variables. So it's so the algorithms we use around this are really designed to be able to take this stuff, kind of process it, and be able to bring back an optimal solution from a whole bunch of different possibilities. And then intelligent agents. So we're seeing a lot of these. Actually, we see a lot of these intelligent agents kind of in action now. All right, so they're fairly small. They're very focused. So we like deleting junk email and finding cheapest airfare. The one we see, actually we'll see this sometimes, is what we call chatbots. So what it is a simulation of somebody on the other end of a chat line. All right, so what it'll do is when you go to a website, it'll pop up and say, hi, how are you? Is there anything I can help you with? And if you say yes, it has a pre-program based upon what, the different responses that people will enter, and it can give you a simulation of a real conversation up to a certain point, at which point it can then switch to a person. But there's a lot of work put into this thing. So chatbots have gotten a little better. It's actually sometimes it's difficult to see if you've actually got a real person at the other end of the line, or if you got a chatbot. All right, and we have different, as I said, we have different ways we're using intelligent agents. So they tend to be very focused, and we use different applications. But probably the best example we have here. So Procter and Gamble, they have what we call their supply chain. And we talked about supply chains just briefly. In this case, a production organization's supply chain is really the connection of tasks and activities running from the supplier through production to the outcomes. The outcomes either being distributors or being retail stores. All right. So the way P&G uses these intelligent agents, it's actually gathering bits of information about what's happening as things are being, if you order something from a supplier, you'll be able to track what the availability, the shipping, basically the transportation information. When will what's your estimated time for arrival? And we'll see things like that. Obviously, if you go and buy something on eBay or buy something on Amazon, it'll give you an estimate of where it is at. It's tracking. They have agents which are tracking package delivery and associating it with your order. Right. And then the same thing is true. You can take that same kind of applicability, put it into like the retail. So what will happen is when a company makes a product, it can either ship it out to a distributor, depending upon what its business, or it can go directly to a retail store. All right, but these things these agents are really, and they're basically small programs. And they're really not doing, they're tasked with very specific things, track this, feed this information. All right, so it stays pretty focused, but what you do is you'll see these things, these agents can be distributed all throughout a process and kind of, gathering bits of information. So what happens is you end up wiring your supply chain end to end with bits of information that you can kind of monitor what's going on. So AI, artificial intelligence, how a computer program can improve performance without having somebody sit down and program it. All right, so a bunch of different things, different techniques. So patterns matching, we've talked about pattern matching, experience, prior learnings, basically gathering this information and then coming back and be able to analyze it. And we see this really kind of behind the scenes on a whole bunch of stuff. So Google searches are, an example of this, because what will happen is you think about the mechanics of when you do a Google search, you get a response back in like a second, half a second, not even a full second. A lot of the stuff, there's a lot of stuff that's built into that helps facilitate the search. Or recommending systems on Amazon or Netflix or HBO Plus, or Siri or Alexa. So kind of voice interaction, kind of giving you the simulation of actually having. There's not somebody, it might disappoint some people, but there's not actually a box inside of your iPhone. There's not a person inside of your iPhone called Siri. Right? It's a program. All right, and what it does, but it's designed to imitate, understand. It can understand voice commands and then translate it into queries or activities based upon, how it's programmed. And the terminology we use modern times is machine learning. So artificial intelligence, as I said, it's been around really a long time. So it's kind of the holy grail of, ultimately of being able to do machine. Of having thinking machines. So, and that summarizes everything we need to know about knowledge management.